Hi there! Remember that I explained the three types of Program Organization Units or POU during the first video. Until now, we were using only the first type. In this video, I will show you how a function can be defined and used to generate a more efficient program during a practical project with the factory I/O. Then, I will implement another project to use function blocks. Alright, let's start the video by designing a simple industrial process inside the factory I/O. Let's add a water tank. As you can see, there is a valve to fill the tank and also a level meter which I will use it to determine the water level. The fill valve can be controlled by a real number between 0 to 10. You can assume that is a voltage which can be generated by a PLC. Also, the level meter produces a voltage between 0 to 10 when the water level changes between 0 to 300 centimeters. Similarly, at the bottom, there is a flow meter and a discharge valve. The valve can be controlled by a real number between 0 to 10, and the flow meter generates a real number between 0 to 10 according to the flow rate of the discharge. Now, let's design a simple control box that will be used to control the water tank. Remember, to change the height of inserted equipment, press the V key on the keyboard. Now let's use two potentiometers to control the valves and the two digital LED displays to show the water level and the discharging flow rate. Okay, the inserted potentiometers support three modes. Let's use the default mode, which generates a voltage between 0 to 10 VDC for the first potentiometer. To have more complexity, let's select -5 to 5 volt for the second potentiometer. Note that I will use the first one to control the fill valve and use the second one to open the discharge valve. Now let me select some appropriate names for them. Similarly, the inserted digital displays support three modes. Let me select the last mode, the integer format, and also select suitable names for them. Alright, I have designed my desired system. Before writing the program, let's test the final project to see its functionality. My program includes 4 networks. Let's start with the first one. Remember, the first potentiometer generates a voltage between 0 to 10 and the fill valve is controlled by a voltage from 0 to 10 volts. So I can easily use a move instruction to control the filling valve directly with the first potentiometer. As we can see, the third network calculates the water level based on the level meter signal and also shows its value on the first digital LED display. Now let me open the fill valve completely. Okay, let's close the fill valve. Note that I have used the second potentiometer for discharging, but its voltage range is not suitable to control the discharging valve. I need to change its range. So I define a function whose task is changing the scale of its input based on this mathematical formula. Inside the second network, it receives the second potentiometer's voltage, which is a number between -5 to 5, and converts that to a number between 0 to 10, which is suitable to control the discharging valve. Now let's open the discharge valve. Note that the third and fourth networks work similarly. They receive produced signals by the level meter and flow meter to display the water level and flow rate on these two digital LED displays respectively. Well, let's open the discharging valve completely. Now let's turn to the programming step. I created a standard project similar to the previous videos. As I mentioned earlier, the received signal from the first potentiometer can be used directly to control the feed valve. So I only need a move instruction. Remember that the potentiometers, valves, and transmitters work based on real numbers. So I will use this data type to handle them. Alright, now I want to write a program to control the discharge valve with the second potentiometer, but there is a problem. As I mentioned earlier, the second potentiometer generates a voltage between -5 to 5 volts, but the discharging valve is controlled by a voltage between 0 and 10. Therefore, I need a program like this that works based on this mathematical formula to change the scale of received input signal from the second potentiometer to an appropriate range. Like the previous videos, I can write the whole of my program here. Instead of that, I want to show you how a function can be defined and used to have a more efficient program. So let me right-click on the application, then select the POU item. As I explained in the first video, it is an abbreviation of Program Organization Unit. As you can see, there are 3 types of POUs. Until now, we used the first choice, program, to write our program's code. I will explain and use the second type, function block, during the next projects. Now let me select the third type, function. It gets some values and at least one output whose data type should be determined. Let's select the real format for that. Let's choose an appropriate name here. It will be used as the function's name and also the name of its first output variable. Note that I can use another language to write my program. Let's continue with the ladder logic diagram. Alright, the new function is created. First, let's look at the declaration section. It has one output, which is a real number. As I mentioned before, a function has some inputs to receive some values. The inputs are defined here. Also, it may need some local variables which can be defined here. Note that local variables will be used only by the created function, meaning another POU like this won't access them. Now let's write my program which will use this mathematical formula to change the scale of its input. Based on this formula, the function needs the minimum and maximum limits of its input and output. Now let's use the math operators that I already explained to implement the formula. Alright, this variable is an input of my function, so after determining its data type, I must select an appropriate scope for that. Now let's click on OK icon. This window says that the new variable is going to be added to my function as its input. Again, let's click on OK. As you can see, the new variable has been considered as the function input. Similarly, the next input, the lower limit of the input variable, should be considered as the function's input. Now on the other side of the subtraction, I need a local variable to store the result. Now let's use another subtraction to calculate this part of the mathematical formula. As you can see, new variables can be defined during the programming step. Now let me define all of them inside the declaration section and then continue the programming step. Well, for the last variable, I forgot to select a real format as its data type. Now let me define my variables and then use them to implement the mathematical formula. Okay, let's continue the programming steps. Alright, this is the desired result. Therefore, I need to use this variable which has been selected as the function's output. Now, let me extend the program to show you how another output can be added. For example, if the input signal is not within its valid range, a bit of memory should be activated to indicate there is an error. Alright, to consider a new variable as the output of the function, its scope should be changed to var output. Well, my second output has been added. Now let's complete the program. Now let's compile the project to ensure there isn't any error. Okay, let's go to the main POU. As you know, the PLC starts its work from the first network of this POU. Therefore, if I don't use the created function here, it won't be executed. As you can see, a category has been added to the right list. Here I can see and use my function. Well, apart from the first input, which is used to enable my function, it has 5 inputs. I will connect the first input to the second potentiometer. As you know, the second potentiometer produces a voltage between -5 to 5 VDC. Also, my desired range for the function's output is 0 to 10 VDC to control the discharge valve. As you know, the selected data type is real for this and these variables. Just to indicate this point, I prefer to write the number 10 with its fraction part, which is equal to 0. On the other side, I connect the first output to the discharge valve. Remember, it can be controlled with a voltage within this range. Although I won't use the second output, let's define a Boolean variable for that. Again, let's use my function to receive the level meter signal whose voltage is between 0 to 10 VDC and convert it to a real number between 0 to 300 centimeters to indicate the water level. Okay, here I have the water level in a real format, but these two digital LED displays accept only integer numbers. So I need to use a conversion instruction, which I explained it during the previous video, to convert this real number to an integer 1 and to send it to the first digital LED display. Similarly, let's write a program to get the flow meter signal, which is a real number between 0 to 10, and convert that into an integer number between 0 to 30. Alright, after designing my system using Factory I/O and also testing the final project, I finished the programming steps with CODESYS. Therefore, all necessary steps related to my project have been done except the linking process between my program and Factory I/O. Because I explained the connection process in the previous projects, let me increase the speed of my video just to show you the connection process. Alright, I tested the project in the beginning of the video. I hope you have enjoyed the project. Okay, I defined a function and used that to have a more efficient program. Now, another project will be implemented inside Factory I/O to teach you how we can define and use the function blocks and what are the main difference between functions and function blocks. Okay, let's start with the final project. As you can see, here there are two tanks. Program can be divided into two parts that are similar together, but they work independently. First, let's test the left tank. If I press the green push button, the filling valve is open for a specific time. As you can see, this digital display determines when the filling process is stopped. Similarly, if the red push button is pressed, my program opens the discharging valve. As you can see, during the discharging process, the green push button is not working. Now let's test the right tank. It works similarly, and as you can see, the programs of the two tanks are quite similar together, except for their filling and discharging times. In this project, we are going to learn how we can use the function blocks to program similar processes but with different parameters. Alright, as the first step, let's design two tank system inside factory I/O. Well, let me start the designing steps with the third predefined system. Note that digital mode has been selected for the tank. In this mode, it has only two digital valves for filling and discharging. Now let me duplicate the water tank systems. Okay, I designed my system. Now let's select appropriate names for the equipment. Let's use the default names for the first tank and change them for the second tank. Note that suitable names always help us during the connection process between the equipment and the program. Remember, the green push buttons that are used for filling are normally open, and the red push buttons that are used for discharging are normally closed. Now let's select the drive option under the File menu. Like the previous videos, here I can connect the equipment to my program via an OPC server. Note that at the bottom, you can see the selected color for each data type. Now, let's launch CODESYS and start the programming step. Alright, there are two tanks with the same performance. The whole of my program can be written here inside the main POU. Instead of this simple way, let's see how we can use the function blocks to make a more efficient program. I explained the function and I used it to implement a mathematical formula. In this project, I need a function block. It works like functions, and I will show you the main difference between function blocks and functions during the programming steps. Well, function blocks usually have some inputs, outputs, and local variables. The main difference between functions and function blocks is that the functions don't store any variable for the next execution or for the next scan cycle, but function blocks use a part of PLC memory to store their local variables. Let's continue. I want to use the green push buttons to open the filling valves. My function block receives the state of push buttons as its input, and it determines the state of filling valves as its output. Now let's use a pulse timer to determine how long the filling valve must be open. Okay, this variable as an input receives a time with this format, which determines how long the filling valves must be open after pressing the green push buttons. Otherwise, the program will use this initial value of 10 seconds instead. Now let's define a variable as an output to store the elapsed time. I forgot to define this variable as an output, so let me change its scope manually. The pulse timer only needs one pulse to start its work. So let's change the type of this contact to detect rising edges, receiving from the green push buttons. Now let's write a similar program to open the discharge valve for a specific time. Remember that the red push buttons, which are used for the discharging process, are normally closed. Now let's add another condition. The two tanks must not open the fill and discharge valves at the same time. As you can see, to implement this condition, I use a normally closed contact of each valve in front of the push buttons. In consequence, if the discharge valve is activated, this contact becomes open. Therefore, the green push button cannot activate its pulse timer or the fill valve. Similarly, if the fill valve is open, the red push button cannot start the discharge process. Alright, this is the program to control the fill and discharge valves of each tank inside this function block whose name is fbtank. The function block has some inputs and outputs. Note that my program needs an important condition to work correctly. It needs to remember the state of these two valves and the timers to determine the state of each valve. Now let's use my function block inside the main POU. I want to use it to control the first tank. As you can see, it needs a variable to work correctly. This variable, whose data type is fbtank, is used to store the local variables of the function block. Now let's delete this contact because I want to execute the function block during each scan cycle. Well, the first input must be connected to the first green push button. Now let's define a time for the filling process. The next input must connect to the red push button. Finally, I can determine a specific time for the discharging process. If I don't determine any time, the default time will be equal to 10 seconds is used. Now let's connect these two outputs to these valves of the first tank and store these outputs with the data types of time in two suitable variables. Alright, let me tell you an important point. Although the name of my variables is similar to the selected names for the input-outputs of my function block, they are not equal together. The exact name of the used variables inside my function block starts with this variable. Pay attention to the full name of the first output of my function block. Alright, this function block will control the fill and discharge processes related to the first tank. Now I need a program to calculate the remaining time of the fill or discharge process and display it on this digital LED display. Let me use a function to write this program. The data type of the function's output should be an integer, since this data type is selected for the two digital displays. So, inside the function, I need to convert the calculated time to an integer number. Alright, first let's use a subtraction instruction to calculate this time. Now I need to convert the calculated time to an integer number using a conversion instruction. Because the conversion instruction gives me the time in milliseconds, I need to divide it by 1000 to represent the calculated time in seconds. Alright, let's compile the program to ensure there isn't any error and then use the function inside the main POU. Alright, let's use the define function whose name is fctimer for displaying the filling process time when the fill valve is open. Based on the first network, the maximum time is 15 seconds and this variable represents the current time. On the other side, I can connect the function output to this digital display. Similarly, let's use the fctimer function again to display the discharging process time. Remember, the default time for the discharging processes is 10 seconds. Okay, this network displays the remaining time of the discharging process on the first digital LED display. Note that based on the program which has been written inside the function block, both valves cannot be opened simultaneously. So the first digital display shows the filling process time when the filling process is activated or the discharging process time when the discharging valve is opened. Now let me test the whole program manually. Let's enable this variable. Later I will connect it to the green push button. Okay, there is a problem with the program because both timers and valves have been enabled for the filling and discharging processes. Let me open the function block to find the mistake. Alright, one variable has been used for these two timers. I must change one of them. Alright, let me test my program again. First, let me enable this input to start the filling process. As you can see, the filling valve is open and the second network is calculating the remaining time for us. Similarly, this input can start the discharging process. It seems the program is working correctly to control the tank. Now I am going to extend my program to control the two tanks. I only need to duplicate these three networks and use suitable variables for their inputs and outputs. Note that I must select a different variable for the second function block to avoid repeating my mistake. Alright, I've finished the programming steps. In this project, I defined a function block fbtank and used it twice. Note that each function block has a special variable to store its parameters such as timers, time. On the other side, functions such as fctimer can be defined and used for programs that don't need to store any parameter. All of the necessary steps related to my project were explained except for making a connection between my program and factory I/O. Because I explained it during the previous videos, let me just review it and speed up the video. If you don't have any problem with the connection process, you can stop the video and do some other useful tasks such as improving my project by yourself. To make connection, first I need to determine which variables must be shared with factory I/O via an OPC server. Then I need to run my virtual controller CODESYS control win-v3 and after that download the program on the virtual controller. The CODESYS cannot detect any controller since I forgot to disable the simulation mode. As you can see, it can find and connect to my controller. Now I need to use kept server ex software to create my OPC server. As you can see, I have already defined this channel with these tags which are connected to the selected variables in my program. The connection quality is good. Now I must open factory I/O to connect the equipment to these tags. Conclusion: we can use the function blocks to implement one program for similar systems with different parameters. In this project, the two tanks used different times to open their fill and discharge valves. Thanks so much for watching this video. I see you in the next one.